All right, I will get started. Gotta sneeze. Hold on. Oh, okay, fine. Okay, so just to keep in mind, we are revising stuff from yesterday. Yesterday we started our new topic on organic chemistry. If you weren't here yesterday, really, really important then that you watch the recording for yesterday's lesson because it was really foundational stuff. The focus was just an introduction to organic chemistry, understanding why carbon was so important for organic chemistry, and then translating organic names like this into drawings of the molecules. So let's do that one first. So whenever we're looking to draw our molecule, the first thing we want to look at is the end of the name, which is this bit here. That is my parent chain, and that tells me basically what I am starting with. So this is my parent. So I always start by looking at that. This A-N-E ending is really important, or looking at these sort of endings are important because they can tell us what sort of functional group we're working with. In this case, we are working with alkanes only so far. So alkanes are really simple. All they are is carbon and hydrogen with single bonds. So it's our simplest of our organic molecules. Are you okay with that so far? Like I said, yesterday was a really important lesson, so you gotta watch it if you missed it. All right, keep going. Okay, so the next bit is that beginning bit of that word, the pent, gives us a lot of information when it comes to number of carbons. Pent is 5 carbons in that main chain. So just as a reminder, some of the things we talked about, if you look here, we were talking, not a good example because this is the branches. 2 is F, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is op. Just so you guys are aware of that. And then 9 is non, and then 10 is dec. We went all the way up to 10 yesterday in my notes. Those notes are scanned and are on Google Classroom if you want to look at those and save yourself the hassle of watching the whole video. So what you guys could hopefully see is that with the pentane, pent is that beginning word here, and then A-N-E tells us we're dealing with an alkane. Cool? Hopefully. All right. This topic is organic chemistry. It is an external, but I'm only going to cover a couple of bits of information for this external, because then we're going to move into our internal spec. Spec requires you to understand some organic chemistry to be able to do it, so that's why I'm doing it that way around. The other nice thing is that it gives you a little bit of a taster of an external. So if you're debating between should I be taking the chemistry course or the science course, it can help you decide. The other thing is, once we finish spec, I'm going to give you guys a choice, if you're doing the chemistry course, of either doing the organic external or the thermochemistry external. And you should hopefully, by the time that we've done all like the organic introduction and the spec, you'll have an idea of whether or not you like organic. I find most kids only want to do one or the other. They're either really good at organic or they're really good at thermo. The thing with organic is that I think organic is easier to get excellence on because there's not a lot of writing. It is a lot of understanding process. So if you're a big picture thinker, organic is good for you. Really easy to get excellence if you know that sort of stuff. If, however, you're not good with that, thermo is the easier of the two. It is a lot easier to get achieved on. It is a lot easier to rope learn the material. But the challenge with thermo is that there is going to be obviously more expectations on the writing and explanations, and there's going to be a calculation component to it. So there's pros and cons to each external. So I recommend you pick one. However, if you're planning to apply to Otago Uni under their health science program, they're going to require 18 credits in a pure science subject, so biology, chemistry, or physics. Don't have to make that decision now, but just keep that in mind that with your science subjects, you're going to need 18, and that means at least in chemistry, you're going to have to sit 2 exams. So keep that in mind with kind of your goals. And if you want to do it in multiple classes, you can, so that way you get more opportunities. So if you do it in bio and chem, only one of the 2 need to be 18, but you might want to give yourself 2 chances. So just keep that in mind that this is leading up to external material as well, so it is worthwhile to learn. All right, so Pent tells me 5, so I'm going to draw 5 carbons down. 1, 2, 3, 4, 5. That represents my parent chain, my base. Are we okay with that so far? All right. So the next thing I then look at are my branches, and these branches are being referred to before. The numbers tell me location on the parent chain. So basically, what carbon is it attached to? Things to keep in mind is that we can only number the chain once. So keep that in mind when we are working, that we can only number the chain once. I'm going to number it from left to right. That seems to just be the habit that I've gotten into, but if you go right to left, that's fine as well. So this is carbon 1, that's carbon 2, carbon 3, carbon 4, carbon 5. Now, you don't need to write those carbon numbers when you're doing the work. I'm just showing you it right now, so that way you can translate the information. Are you okay with that so far? All right. Next thing I have here are these bits, which says ethyl and methyl. That tells you the length of the carbon branch. So if I'm thinking about what I was looking at earlier, if I wanted to write that, that'd be ethyl. Ethyl means 2. So this tells me that this carbon chain has 2. Methyl means 1. So this carbon chain only has 1 carbon. 2 carbons, 1 carbon. And I'll do the other names. So this would be propyl, that would be butyl, pentyl, hexyl, heptyl, and octyl. Very unlikely you will ever get anything past 3 though, because then it's not the longest chain anymore. Okay with that so far? So the key thing to keep in mind is that when it comes to the parent chain, 2 things that decide what is the parent chain. The first is the functional group, which we haven't started talking about yet. The second thing is longest chain, so which is the longest bit. So currently that's the longest one. All right, so what this tells me is that carbon number 3, I should have 2 carbons chain coming off. And then carbon number 2, I should have a 1 carbon chain coming off. Doesn't matter if they're both up or both down, or one's up or one down. I'm doing 1 up and 1 down, so that way I have more space. Are you okay with that so far? All right. Last step is that I need to fill in the hydrogens. So I have to keep in mind when I'm filling in the hydrogens that carbon can only have 4 bonds. Or I should say has to have 4 bonds. So the idea is I'm going to fill in any missing bonds. I should somewhere.
Is this coming up?
Yeah. Let's do this. All right. So carbon has to have 4 bonds. Whatever isn't bonded to another carbon, I fill with hydrogen. So when I look at this N carbon, I see that it's bonded to 1 other carbon. So how many hydrogens should I have there? 3 to make my 4. So that carbon's bonded there, and then 3 additional. This carbon up here bonded to one other carbon, so 3 as well. This carbon here is bonded to 1, 2, 3. So how many hydrogens do I need on that one? Just the 1. So those numbers aren't there to indicate anything special. It's just to help us number carbons. I'm just going to cross them out so you don't get confused. All right, this carbon here. 1, 2, 3. So how many hydrogens? Just the 1. Cross this guy out. All right, this carbon here. 1, 2. So just 2. This carbon here. Only 1 bonded to it, so it's going to need 3 hydrogens. This carbon over here, 1, 2, so just 2. And I'm just going to get rid of the little numbers on the side so we don't get confused. All right, the last one, 1, so that's going to be 3. And that's how I would draw that molecule. If it helps, I will expand it out, because I know there were people that weren't here the other day. And I don't like to expand it out because I find that it's really, really messy, but it's easier when it comes to trying to count what's going on. Okay, so that's the same carbon structure. I'm just showing it to you extended because I know a lot of people are like, what's going on? So you see, when I'm drawing this, each carbon should have 4 things bonded to it. So this is the extended, come on, you can do this. This is the extended format, so you can see all the hydrogens and how everyone's bonded. This here is the condensed formula. So I'm not actually like showing all the hydrogens location-wise. This one carbon here, we can see there's 3 hydrogens attached to it. This one over here, 1, 2, 3, and that's where it's getting that 1. This guy over here, 1, 2, 3, and that's where it's getting its 1. This guy over here, 1, 2, that's where it's getting that 2. This guy over here, 1, 2, 3, that's where it's getting its 3. This guy here, 1, 2, 3, 4, that's where it's getting the 2 hydrogens. You can write it either way. Both will be accepted on the exam. The reason why I condense it down, though, is to make it tidier, because you can see like it's like a traffic jam of hydrogens right now. All right, are we okay with that? Okay, cool. Are you ready for some more information, or do you guys need some time to just work on your drawing? So the homework that I gave you guys yesterday. You want the homework time? Okay. I'll give you 10 minutes of practicing that sort of stuff. It gives the people that were absent yesterday a chance to kind of look over the notes. And then I'll go over how to go the other direction, naming these guys. Okay? Okay, cool. All right, can you guys open up that little packet that I gave you and go to the 3rd page, so aka the 2nd page of the booklet that says with the branching side chains, alkanes. All right, and I'll just basically use these as examples to explain what we are doing when it comes to the naming of our alkanes. So now we are going in the other direction. We're being given the drawing, and from the drawing we have to then decide what the name is of that organic molecule. Some things to keep in mind is you want to find the longest chain possible. So for example, when I'm looking at this one here, we have the option of going 1, 2, 3 or 1, 2, 3. So either one of those chains are fine because they are both the longest chain. So do keep that in mind. You just need to find the longest chain possible. If you have multiple choices with the same possibility, then you don't have to worry about it because the naming is still going to be the same at the end of the day. Once you have identified the longest chain, then you're also mindful of the branches that come off that chain. So, there we go. All right, I think the best way to kind of learn how to do this is through examples. So I'll do a couple of examples. There are some fairly easy, straightforward ones, and there's some more complicated ones that I'm happy to do as well. All right, so I'll start with these two because these are nice, easy examples. So I'm just going to put things in different colors so we can see the way I am numbering my chains to help us identify which one's going to be our longest chain. So first off, I can start with this carbon and end with that carbon. 1, 2, 3, 4, 5. That's one possibility. The other possibility is that I start with this carbon over here and I go, okay, that's carbon 1, 2, 3, 4. I can also number things in the other direction. That's fine as well. So 1, 2, 3, 4, 5. Same thing, I can start with this carbon here and go, okay, that's 1, 2, 3, 4. There's lots of different ways I can number it. The main thing I'm looking for is which one's the longest chain. So the longest chain is this chain here, and I can again number it in either direction because it doesn't make a difference. So let's first identify that longest chain, and this here is my longest chain. The longest chain here has 5 carbons, so what should I call it? Pentane. All right. The next thing I then have to decide is, okay, what's happening with the branches? So I notice here that since this is my main chain, I'm saying that this here is a branch that's coming off of it. Do you agree with that so far? All right, since the branch is only one, what would I call it? Methyl. So I have methyl pentane. Now, last thing I need to do is figure out what number to assign methyl, so that way I can tell people where is that methyl located. And I can see people are already telling me the number 3, which is correct. 3 is the number. Thank you. Does it matter if I go this way or that way? No. Either way, my number is going to be 3. So if I go 1 to 5 that way, my number is 3. If I go 1 to 5 this way, my number is still 3. So I would say it is 3-methyl pentane. We good? All right, I'll do some examples and then you can see different varieties of them. All right, this one here, we'll start from left to right. 1, 2, 3, 4. If I instead choose to use this carbon over here, and I go 1, 2, 3, 4, are they the same? Yes. Yeah. So it doesn't matter which chain I choose as my main chain. Either way, you see how carbon number 2 is going to have a methyl coming off of it. So it doesn't matter. I just got to pick one. All right. So I personally like to keep this guy the main chain because it's easier for my brain if I'm just thinking about straight lines. All right. So there's 4. So what would I call it? Butane. What's coming off of it? 1, so that's my methyl. And number 2. What's the other option of number could I give it? 3. But am I going to give it 3? No. Why? Because we're starting from the opposite point. The other thing to keep in mind when we are doing naming of alkanes is we want to give it the lowest number possible. So if I had 2 choices of a 2 or a 3, I want to go with the 2 because that's the lower number. Should I repeat that? You guys okay? You good? All right, so this one here is also going to be 2-methyl butane. Cool. So those are the things to keep in mind. I will show you guys some more complicated ones because I'm mindful that you guys might get tripped up somewhere. Are there any on this page you would like me to do as an example? Or is the other page more important? You guys think you can figure out these ones just fine?
M.
M or N? M? Yep. All right. So this one, again, we have to play around to see where the numbers are going because I'm looking for longest chain possible. So don't be thrown off by the fact that this guy is coming down because it's still part of that same long chain. So I'm going to go 1, 2, 3, 4, 5, 6. That one's 7, 8. And if I go this way, it would just be 7, right? So this is my longest chain going that way around, like a little snake. So that's my longest chain. You guys see how I found that one? Because if I went the other way, it would just be 7. All right, 8 is what? Octane. All right, what do I have coming off of it? How many carbons is there? This one? 1, because this is my branch. That 1, 2, and that 1, 2, that's part of the main chain. So you don't, they're not, this is not an ethyl, this is not an ethyl, because this is part of the main chain. So this is a methyl.
Oh.
Yeah. Yeah. If these guys were located elsewhere, potentially.
Oh.
So don't be thrown off just by the fact that they're like coming, like they look like they're coming off. When you do the count, that's part of the longest chain. So these are not branches, these are part of the main chain. So that's methyl, and then what would I number it as? So if I number it this way, it's 6. If I number it the other way, and I go 1, 2, 3, is that the lower number, 3 or 6? 3. So this would be 3 methyl. So this is a methyl because it's 1 carbon. These 2 guys here and here are part of the parent. They're not branches. And then when I go to number it, I had 2 choices of the numbers, either the number 6 or the number 3. Because I can number it the other way, in the other direction. So if I number it in the other direction, and this carbon is carbon number 1, 1, 2, 3, 4, 5, 6, 7, 8. So you're only allowed to number it once, so I've chosen the blue pathway, because the blue pathway gives my methyl a lower number.
Hey, what? 3?
1, 2, 3.
You not count up.
No, because this is the branch coming off. So this is carbon number 1. That's carbon number 2. That's carbon number 3. The branch is coming off carbon number 3. Yeah. So I don't count this carbon as part of the branch. I'm saying, of a part of the numbering system. I'm saying that this methyl is coming off of carbon number 3.
So it takes 3 steps to get to that.
It takes 3 steps to get to that methyl. Okay? And I think Mena was asking me to do the other page as well. Just seeing what time we have. 40. Okay. Do you want me to do one on the other page? Because these are the complicated ones. They're all complicated. This one's more complicated. All right, these guys here have multiple branches, and on top of that, you might have a different number combination depending on which one gives you the better combo. So, things to keep in mind. I might do you guys want me to just to do one of these guys as an example, or this one up here?
Yes, please.
That one.
One on the bottom? Okay. Any preference to which one I do? E, because it's the hardest? E or F? F? Okay. D? Which one do you guys want me to do? You gotta pick one.
F.
I hear more for F. It's fine. All right. So again, we are looking for longest chains. To help me kind of figure that out, I'm looking at this carbon here, and I see there's a 3, and there's a 2. So I know the longest chain has to use one of these 2 branches, because those are longer than 2. Do you see how I made that thought process? Nope. All right, want me to backtrack? Yes. Okay. So I see this carbon right here in the center. Yes. And this carbon is definitely going to be part of the parent chain. Now, I have to decide which direction I want to go with my parent chain. If I go up here, there's only 2 carbons. If I go this way, it's 3. And if I go down this way, it's also 3. So either I go down or I go straight. This guy here is going to be a branch. I know that already. Well, we'll see. All right, here's another carbon that I know is going to be in my parent chain. This way is 1, that way is 2. So this should be part of my parent chain as well. This should be here, a branch. All right? Does it matter if I go straight that way or going down? No. Doesn't matter because the numbering are still the same. They're both going to be 3. So one of these 2 is going to be a branch. I'm going to go this way because that's just the way my brain likes to work. All right, so 1, 2, 3, 4, 5, 6, 7, 8. And I want to number it in the other direction. Sorry, let's just start with the 8. So 8 tells me what? Octane. All right, now I need to figure out which is the best numbering pattern. So the way we figure that out is like which one is going to give me the lowest possible combinations. So right now, I have 3 branches. With the current numbering system, those 3 branches would have a 3, a 5, and a 5. That's my first combination. If I number in the other direction, 1, 2, 3, 4, 5, 6, 7, 8. The 2 branches here are coming off carbon number 4. So I have a 4 and a 4, and I have a 6. 3. So let's do the math. 3 plus 3 is 5, plus 5 plus 5 is 10, plus another 3, 13. And then if I do 4 and 6, that's 10, and that's 14. So which one gives me the lowest possible combination? Lowest. 13. So I want to use the purple route. Purple route. All right. So this 2 is an ethyl. This 1 is a methyl. And then this 3 is a propyl. Huh? All right, so the way I order this is I order this in alphabetical order. So E goes first, and E is on carbon number 3. Sorry, 5. So we have 5 ethyl.
5 ethyl.
Then what's first, M or P?
M.
So that is on carbon number 3. 3 methyl.
3 methyl.
And then what's the propyl on? Carbon number? 5. So 5 propyl.
3 methyl.
5. 1, 2, 3, 4, 5.
4, 5.
5. This guy's 5. So 5 ethyl, 3 methyl, 5 propyl. Octane is the name of that molecule. All right?
You got it.
Got it? All right, I'm going to let you guys sit and work. Just checking to see how you guys are going. So we have 10 minutes left. Do you guys want to use any preferred activity time or save it? Save it? Okay. So you're working to the bell. Other thing is, do you guys want Monday just to practice this?
Yes.
Yeah?
Yes, I want money.
You want money? So what I can do for Monday is I can give you some more time to practice this. I can get some more example problems. I do have a Kahoot and a Gimkit made, so we can play those two on Monday once you guys feel a little bit more confident. Sound good? All right. Time's yours.